Okay, we're going to look at some curve sketching with polynomials. So within this, there's going to be a lot that we'll take from curve sketching with differentiation, which involved stationary points, their nature, and where the thing cuts the x and the y-axis, but we just need to involve some synthetic division. Okay, so let's just explain as we go. So example 1, we're going to sketch the graph of f of x equals x cubed minus x squared minus 8x plus 12. Okay, so the first thing that I'm going to do is check the y-axis. So I check the y-axis by making x equal to 0. So let's do that. So f of 0 equals 0 cubed minus 0 squared minus 8 lots of 0 plus 12. And that'll give me 12. Okay, so I cut the y-axis at 0, 12. Next thing I'm going to do is cut, or rather check the x-axis. What's true in the x-axis? Y is equal to 0. So the function in itself is equal to 0. X cubed minus x squared minus 8x plus 12 is equal to 0. Now that is a polynomial. Okay, so to get the roots, to get where the thing cuts the x-axis, I need to do synthetic division. So this is one of these ones where I need to do a bit of trial and error. So what numbers will work or could work? It's all your positive and negative factors of 12. So plus or minus 1, 2, 3, 4, 6 and 12. Okay, so let's try to get going 1. Okay, coefficients are going to be 1, minus 1, minus 8, 12. Drop the 1 down. 1 times 1 is 1. 1 minus 1 is 0. 0 times 1 is 0. 0 minus 8 is minus 8. Minus 8 times 1 is minus 8. Minus 8 plus 12 is 4. Didn't work. Let's try another one. Okay, so this time I'm going to try minus 1. Okay, so coefficients then are 1 minus 1, minus 8 and 12. Drop the 1 down. 1 times minus 1 is minus 1. Minus 1 minus 1 is minus 2. Minus 2 times minus 1 is 2. 2 minus 8 is minus 6. Minus 6 times minus 1 is 6. 6 plus 12 is 18. Okay, it didn't work. Let's try 2. Okay, so we can expect from our trial and error approach here that some of these factors won't work. That's normal. Okay, so let's try 2. Drop 1 down. 1 times 2 is 2. 2 minus 1 is 1. 1 times 2 is 2. 2 minus 8 is minus 6. Minus 6 times 2 is minus 12. 12 minus 12 is 0. Okay, so that worked. So r equals 0, therefore x minus 2 is a factor. Okay, so I've got x minus 2 and I've got a trinomial here, which is x squared plus x minus 6. And I'm looking to solve this thing, so I'll make it equal to 0. X minus 2 bracket, two numbers that multiply give minus 6. I had to give 1, that's 3 and minus 2 is equal to 0. I've now got x minus 2 equals 0 twice. And I've got x plus 3 equals 0. So that's x equals 2 and x equals minus 3. So there's my 2 points that I cut the x-axis, 2, 0 and minus 3, 0. Okay, so I'm now just going to list some important information that I found out, which is 2, 0 and minus 3, 0 and 0, 12. That's the points at which I cut the axis. Okay, next move, I'm going to find the stationary points. So I find the stationary points by differentiate the function. Okay, so x cubed differentiating, I'll get 3x squared minus x squared minus 2x minus 8x minus 8, and the 12 goes, and then make equal to 0 and make a statement for stationary points. F dashed x is equal to 0. Okay. It's then 3 times minus 8 is minus 24. Two numbers that multiply give minus 24. That together give minus 2 is minus 6 and 4. So this is our national 5 bit. Okay, so drop minus 6 in there and 4 in there. Drop 3x in here and 3x in here. Okay, look at the first bracket. I can take out a common factor of 3, brings me down to x minus 2. Second bracket is still 3x plus 4. I've got x minus 2 equals 0, or 3x plus 4 is equal to 0. X equals 2, 3x equals minus 4, and x equals minus 4 over 3. Okay, I now need to find the y coordinates, so I'm going to sub the x coordinate back into the original function then. So f of 2 is equal to 2 cubed minus 2 squared minus 8 lots of 2 plus 12. That's 8 minus 4 minus 16 plus 12. 8 minus 4 is 4, 4 minus 16 is minus 12. Minus 12 plus 12 is 0, so that'll give me stationary point 1. Stationary point 1 then is 2, 0. Okay. Stationary point 2. Okay, so stationary point 2 occurred when x was equal to minus 4 over 3. So that is minus 4 over 3 cubed minus 4 over 3 squared minus 8 lots of minus 4 over 3 plus 12. Then enter that in the calculator. Okay, so that should give you 500 over 27. Okay, I now need to go after the nature of the stationary points. So I'm going to set up a nature table. Okay, so x, f dashed x, slope. Okay, so the stationary points occur at minus 4 over 3 and 2. So I need to look before, between and after. Before minus 4 over 3, well, that could be minus 2. Between minus 4 over 3 and 2, that could be 0. And after 2, that could be 3. So I'm investigating the gradient of the functions. That would go into the differentiated function. Okay, so just a reminder of the differentiated function. That's 3x squared minus 2x minus 8. So let's try f dash minus 2. 3 lots of minus 2 squared minus 2 lots of minus 2 minus 8. Minus 2 squared is 4 times 3 is 12. Plus 4 minus 8. That's 8. That's a positive result. Slope's gone up. Okay, now let's try f of 0. F of 0, 3 lots of 0 squared minus 2 lots of 0 minus 8 will give me minus 8. That's a negative result. Slope's going down. Now let's try 3 f dash 3. 3 lots of 3 squared minus 2 lots of 3 minus 8. 3 squared is 9 times 3 is 27. Minus 6 minus 8. That will give me 13. That's a positive result. So I can see that I've got a max and a min. So it's a max turning point at minus 4 over 3, 527ths. And it's a min turning point at 2, 0. So I need to just take all that information now and plug it into a curve. Okay, so let's get the axis first. So minus 3 and 2, cutting at 12, and minus 4 over 3, 527ths. That might be a bit there. I'll speak a wee bit more about sketching a curve accurately tomorrow. I know that that's a max, and I know that I've got a min here. So we'll look something like that. Okay, so that's 10 minutes for that. I'm not going to do an example 2, so just go back through that one again, go through your steps. So your steps are, first of all, where do you cut the y-axis? You make x equal to 0. dead straightforward. Then you want to check the x-axis by making y equal to 0. That's making the function equal to 0. Now that's the bit that's going to probably involve synthetic division. You then need to factorise and solve, and that's where I got the answers of -3 and 2 of the roots. Okay, once you get that, it's then differentiation and stationary points. So differentiate the thing, make it equal to 0, find the stationary points. They occurred at -4/3 and 2. Sub -4/3 and 2 back into the original function. That will give you the y coordinates, the stationary points. You then need to go after the nature table, get your neighbouring values, put them into the differentiated functions, and that should then tell you about the nature. Finally, you can execute it by sketching the curve. Okay, I'll do one example of that during the double tomorrow.